Um, all right, well, welcome to the final exam review. I'm confident most of you are pushing through one more push and we are done with this term and on to bigger and brighter things, hopefully. So I guess I'll start and kind of maybe format it like last time where, I guess I'll just open up the floor for any questions that you have about the exam, like format or the exam in general. And then after that, when we go into the content section, I'll start with a review of things that I really think that you should pay attention to going into the exam, and then open it up for questions that you might have. So what questions do you have just about the format of the exam?
So how many questions is it going to be since it's merged into one test?
Yeah, it's basically like the same thing as you've had in the past, except it's just all under one test and timed under one test. The reason I do it that way is to make it comparable to the in-person sections who receive an identical exam, right? And so the difference is like for in-person sections, for the first exams, they come in and they do a conceptual portion, and then they do a separate computational portion. But for finals, since there's like a final exam schedule and everyone comes in and they only have one final exam period, I combine both of them under one section and one time limit so that it's comparable to what it would be as if you were taking it in class. Does that make sense?
Yeah.
Okay. So in terms of how many questions are on it, that's a little rough. Maybe not so much for the conceptual portion, but for the computational portion, it depends on how you kind of chalk it up, right? Because you'll have like 2 or 3 problems to do, but each problem has multiple components. So I don't know if the number of questions is a good metric, but it will be comparable to what you had on the previous 2 exams in terms of how much content, how many questions.
And then I had another question. It's not really like the structure of it, but I noticed in the study guide, it had chapter 9 in there, and we didn't really go over chapter 9 on. So are we going to be tested on chapter 9?
Oh my gosh, I can't believe it's in there. Yeah, no, you're not. That's an error. So good.
Okay.
I didn't catch that. I did not catch that. Yeah, you're not doing chapter 9 at all. Yeah.
Okay.
I need to make an announcement about that. I can't believe I didn't catch that. Yeah, it's not going to be in there.
Okay, I was kind of like low-key stressing, so that
yeah. Yeah, it's not going to be there. So on that note, I just want to emphasize, like, is the exam cumulative? Technically, yes. However, if you're getting a question that is from a prior exam period that's not on a NOVA, it's not going to be as in-depth as what you would have had on the specific exam covering that. So the questions that are from prior sections are pretty main point focused. There's the lion's share of the questions are focused on ANOVA, right? But you might get some questions that ask you about the nature of standard deviation, or what does a correlation mean, or things like that. But And I'll just say that, you know, in the computational, I wouldn't put too much time into doing, you know, frequency tables, right? I would focus more on ANOVA. So anything's fair game, but you would be best spending your time focusing on the big picture for the older stuff, and 90% of your time should be on ANOVA. Any other questions on the exam? So, okay, I'm going to point out, you know, this cumulative content section. This really is where there's a lot of questions in this. I'll just say it right out. It is imperative that you're able to determine, kind of like last exam, but this is over the whole semester, like read a research scenario and determine what the appropriate statistical test is to conduct. Wait, you're not seeing my screen, are you? Are you seeing?
We see the study guide.
Okay, do you? Okay, all right. It didn't have the green border. I don't know why, but okay, good to know. So essentially you'll be given, there's a whole section on picking the appropriate statistical test. And you'll need to be able to read a research scenario and then determine what test you need to do. Now, I have provided you with a how to pick the appropriate test flowchart. And this is an example of it. Here, let me. Okay, so you can see this flowchart now, right?
Yeah.
Okay. If you understand how to accurately answer each of the questions, there should be no reason why you cannot pick the appropriate test. However, it seems that this is obviously easier said than done, even with the flowchart. A lot of people struggle with this. And so given the volume of questions that focus on this content, I think it would be wise to go over a couple. So first, let's just talk about about how to answer these questions, right? So identify the independent variable. Well, you need to know what an IV is. I'm hoping you do, but just for clarification, the independent variable is the variable that is either the predictor or it is the variable that's manipulated by the researcher. The dependent variable, on the other hand, is like the outcome, right? Another way of thinking about it is that the dependent variable should depend on the independent variable. Okay, so we need to identify if the independent variable is quantitative or qualitative. So a quantitative independent variable is going to be something that you can do math on. Like you can add, subtract, multiply, divide. A qualitative variable is a variable in which doing math on it wouldn't make any sense. It would be like 0 means female, 1 means male. You can't add that. It doesn't make sense. Or ethnicity, or placebo versus treatment group, right? It doesn't make sense to do math on those, right? So if you can make that distinction, you're good. And if you have a qualitative independent variable, that means you know it's not a Pearson correlation. In this class, if you have a quantitative independent variable, the only test that we're doing is a correlation. You could say a linear regression as well. I'll add that to it, but they're, pretty similar. Whoop. Okay. Next question. How many independent variables are there, right? So if it's qualitative, how many independent variables are there? Now, this is really confusing, or a source of confusion for a lot of people. And the reason is because it's very simple to confuse how many IVs versus how many levels the IVs have. So if we had the IV size of beverage, it might have the levels small, medium, large. But that's one independent variable, right? The variable is what contains the levels small, medium, large. Drink size is the IV, and small, medium, and large are the levels. So if people mess up on this kind of point in the flow chart, that's typically why, because it might be easy to think, oh, well, there's three IVs, right? But really there's only one. So the IV is the kind of the umbrella that contains the lower levels of that IV. So if you have two IVs, which you might have treatment versus control, and then the second IV might be pre-post, right? Then you're going, if you have two independent IVs, it's guaranteed in this class to be a two-way factorial ANOVA, right? But say it's not, okay? You have one independent variable, right? We'll just go with drink size, right? Small, medium, large. Then we go down to this area. How many groups, levels, or conditions does the IV have? Well, if it has three or more, like drink size, then you're going over here, right? And so if you understand how to ask the question above, how many IVs, you'll probably also understand how to distinguish levels from IVs and get this question correct. But so if it's three or more levels, right, we ask, are the observations in each group independent, randomly assigned, or are they correlated pairs of scores, right? In other words, is it between subjects or within subjects in its design? Do we have independent groups that people were randomly assigned to, and each group contains unique people? Or do we have three different, typically time periods, where the same people get something different in each time, right? But it's the same people in each group. So if you're dealing with independent groups or a between groups design, you're going to have a one-way between groups ANOVA. And if everyone gets, like if we were doing a study, I'll just go through an example. If we're doing a study and we wanted to know what the preference for drink size was among people, and we had them, we got 30 people, we randomly selected 10 and put them in the small group. We randomly selected 10 more, put them in the medium group, randomly selected 10 more, put them in the large group, and we said, how much did you enjoy your beverage, right? If we were comparing how much they enjoyed the beverage across drink size, right, this would be a between groups design because there's unique people in each group. However, we could do the same study in a repeated measures design where we had 10 people, and at time point 1, people had a small. And then a week later, they had a medium. And then a week later, they had a large. And we in that design would be repeated measures because each person is receiving all three levels of the independent variable, and we're comparing them to themselves. And so in that instance, you would be dealing with a one-way repeated measures ANOVA. Okay. All right. So that handles if we have an IV with 3 or more groups. What if we have an IV with 2 groups? Well, then we're asking the same thing. Is it between subjects or within subjects? Right here. This is the exact same question as we're asking over here with ANOVA, but we're asking for it when you have 2 levels, right? And if it's an independent groups, you should be familiar with this from the last exam, I hope, right? Then it's going to be an independent samples t-test. If it's a repeated measures, it's going to be a correlated groups t-test. Okay, and then what if you only have an IV with 1 level? Right, well, here we're in the 1 sample category, and you just need to distinguish if it's a z-test or a t-test, right? So if you have the standard deviation, then it's a 1 sample z-test. If you don't, and you have to estimate it, it's a 1 sample t-test. So I'm hoping that review might have been helpful, but I want to put it to the test. So let's go through an example. So you tell me, I'll keep this up for a second, and then let's walk through that flowchart. Okay, we good on that? Let's go back and look at the flowchart. Okay, is the independent variable quantitative or qualitative? What is the independent variable?
Is it the brake pedal?
Yeah, it's the condition. Yeah, so we have the 2 conditions of brake pedal. We have normal brake pedal and altered brake pedal, right? And so is that quantitative or is that qualitative?
It's qualitative.
That's right, it's qualitative. It's like gender, right? Or, drink size, right? It's not like number of feet, right? Or miles per hour, right? So this is a qualitative independent variable. So then we're going, now how many independent variables are there?
Is it just 1?
That's right, it's just 1. This is the question that everyone gets screwed up on. This is it, right? So good job on that. It's just 1 independent variable, right? And the independent variable is what we could say pedal format or whatever, okay? All right, so now we go to the next question. How many groups or levels does the IV have?
Is it just 2? Because it either works or it doesn't work.
Well, it's the pedal location, right? Was it working or just a different location?
Oh, I don't actually remember. I just
Standard place or alternate place, right?
okay.
So yeah, but yeah, you're right. Same thing. So it's 2 levels, right? And now, are these independent or correlated, right? In other words, did every person get the same thing? Did all people use both pedals? Or did we randomly select some people to get 1 pedal and then compare them to a random selection of other people who received the other pedal?
It's correlated because it was the same 10 people.
There you go. And that's your answer. Correlated groups t-test. Good job. That's awesome. All right, let's try another one. That's a very good job. All right, so Here we go. A psychologist studying proofreading suspects that the number of errors in the first part of a manuscript might affect how closely a proofreader scans the end of the manuscript. Proofreaders read one of two manuscripts that had either many or few errors on the first 5 pages, and the same number of errors on the last 5 pages. The manuscript is either printed on paper or appears on a computer screen, and the researcher recorded the number of errors missed on the last 5 pages. All right, let's go back up. Whoop. Here we go. So, is the independent variable quantitative or qualitative?
Qualitative.
That's right. How many independent variables are there?
Would it still be 1? Because it's the errors you're looking at?
Well, that's the dependent variable,
Oh, true.
right? So, or actually, wait, no, hold on. Oh, well, yeah, it is, they're looking at, the outcome is errors, but there's also few errors versus many errors, right? So it's kind of confusing because the errors that they find on the last 5 pages is the dependent variable, but the errors in the first half of the manuscript is the independent variable. So tricky language here. So let's look at it again and see how many independent variables there are. So to me, it seems like we've got one independent variable that represents the number of errors on the first 5 pages, which has the levels of many or few. And then there's a second independent variable, which you could call format. And it's either paper or computer screen. Right? So here we have an example. Oh, why does it keep going backwards? There we go. Here we have an example of 2 independent variables. Does that make sense?
Yeah, it was just the wording for the first independent kind of confused me for a second, but that makes sense now.
Yeah, okay. Yeah, it's yeah, some of this stuff is a little confusing. Yeah, it gets easier as you go through them, for sure. But okay, so we're done with that one. I guess we'll do another one here. A researcher studied the relation between stressors and physical symptoms, headaches, sleeplessness, stomach pains, etc., during final exams in a sample of 60 college students. Students completed a questionnaire that assessed the total number of physical symptoms experienced during exam period, as well as a measure of stress, with higher numbers indicating greater stress for this same time period. So, okay, so we got these students and we're looking for a relationship. And so they give these students a questionnaire that measures their physical symptoms and a measure of stress. And we want to determine the relationship between those. So let's go back and, oh, I keep going the wrong direction. So, all right. Is the independent variable quantitative or qualitative?
Qualitative.
Why?
Because isn't it you're testing stressors and the physical symptoms.
How are they measured?
By ranks.
By scales, right? You give
Yeah.
them a like some kind of self-report scale of how much stress did you get today? You know, how stressed do you feel right now? Like 20 questions on that. And then you average it up and you get their average level of stress. And then there's the physical symptoms, which is kind of similar. You know, did you feel back pain? Did you have a headache? Right? These kinds of things. And you add up their responses and you get an average number. And so we have two numbers, and like when you're averaging the responses to the physical symptoms, you might end up with, say, you know, if it's a 1 to 5 scale, someone might have a 2.937. And then on the stress, someone might have a 3.64. Right? So you see, this is a little tricky one, right? Because it's really important to understand, like to pick out this distinction between qualitative and quantitative. And this goes back all the way to like the first week of class, right? And so, so the question is, can you do math on it, right? Does it make sense? Does it make sense to be able to do math? You can do math on stress scores, right? You can do math on physical symptom scores. Typically, when we're talking about qualitative, we're talking about categories, right? Like different groups. And so on one hand, an argument could be made, which is outside of scope of this class, that scale scores are qualitative. But certainly what we know here is that you can do math on the scores. And I think another big hint here is this trigger word. We're looking for a relationship, right? Relationship means Pearson correlation, right? So this one is, so how can I be helpful? I don't want to just ramble on, but how can I be helpful in making this distinction easier?
So like the only reason I thought maybe it would have been like qualitative is because it said in the experiment they tested the stressors, but then also the physical symptoms of multiple physical symptoms. So I guess maybe if I saw like the data, like the scores, right, I probably would have got a better picture than just reading it alone.
Right.
Well, it's just confusing of like testing like the headaches and all the other stuff that kind of threw me off.
Right. It's easy to kind of think, oh, each one of those is a different category, and it could be a different IV even. Like if they were measuring headaches and backaches and all that kind of stuff, you could design a study where each one of those is a level of an independent variable. In this case, yeah, so the measurement, it was a 1 to 100 scale, right? So that, I think that's really kind of the thing that should cue you, right? Is you're not going to have an independent variable with 100 levels, right? So that, and this is a little tricky. This is one of the trickier ones. And this is kind of the crown jewel of the entire class, is this kind of process. And the reason, I mean, just so I'm not doing this to try to like, because it's a question I like. I think that to you, as someone who's presumably quite interested in psychology, that this is really the meat and potatoes. This is where, when you're presented with some kind of issue in psychology and you need to figure out how you would test it, right? Knowing you can always go back and look up how to do an ANOVA. You can always go back and look up what the equation for a t-test is. But you need to, it's really important that you come out of this class knowing what test to do, right? If you can come out knowing what test to do, then you can go back and refresh yourself later about how to do the test, right? But every other class that you take as you get into depth courses in psychology, many of these classes are going to rely heavily on peer-reviewed journals that have a lot of these statistics in it and a lot of these research designs. And my goal, my overarching goal of this class isn't that you come out knowing how to do having memorized the ANOVA formulas by hand, right? It's that you can read one of these articles and be like, oh yeah, it makes sense how they designed this and why they used a t-test, an independent group's t-test to test it, right? And yeah, so anyway, want to try one more? Okay, so a teacher wanted to know if using a student's own name in a story affected a child's attention span during reading. Students from the teacher's class read a story in which either the typical character names were used, like Dick and Jane, or one of the characters had the same name as the child reading the story. The teacher carefully measured the amount of time each student spent reading the story. So, where do we start here? Okay. What is the independent variable?
Is it the type of names?
Type of names. That's right. Type of names. So you would have type of names. And is that the only independent variable? Actually, I'm kind of getting ahead of myself here. Is that qualitative or quantitative? That's a better question.
Qualitative.
That is qualitative, right? We got two categories, two groups. Okay. How many independent variables are there?
Is it just one because of the type of names, and then the dependent would be the amount of time?
That's right. Yeah, it's just one, right? It's just one independent variable. Okay, so how many levels does that independent variable have?
2, because it's the regular names and then the specific name.
There you go. And this is the one this is kind of tricky on this one, right? Are the observations in each group independent or are they correlated? In other words, is it between subjects or is it within subjects or repeated measures design? Now, if we go back to the question, I just want to highlight this. It doesn't really say, but think about what this experiment would be doing. Would it make sense to have each student read the story with the typical character names and then at a later time read the story with their name?
No, so it would be independent because it's randomly assigned.
Exactly, right. So it doesn't spell it out for you, but thinking through that, like, would give you a sense. You wouldn't really be able to reliably use a repeated measures design here. You would get what you'll learn more about this in research methods, but you'll get like carryover effects, how they performed when reading it or their exposure to the story at time one would have an influence on how they reacted at time two, right? So you wouldn't use that method in this sense. Okay, last one. Last one. A social worker employed by a managed care firm was asked to determine whether there was any clear difference in the length of stay of inpatients with different categories of diagnosis. The social worker went through the records of several inpatient mental facilities and randomly selected a large number of cases. For each case, the number of days spent in the treatment was recorded as the patient's diagnostic category, as was the patient's diagnostic category: affective disorder, cognitive disorder, or drug-related disorder. Okay, so what's our dependent variable, right? It's going to be the length of stay, right? And then this social worker goes through and categorizes people according to their diagnosis. So now let's go back to the original screen. All right. Is the independent variable quantitative or qualitative?
Qualitative.
It is qualitative. How many independent variables are there? Be careful.
One.
There's one. That's right. There's only one. Okay. How many groups or levels did it have?
3.
3. That's right. Okay. And was it independent, randomly assigned, or correlated?
Independent random.
There you go. One way between subjects and ANOVA. That's perfect. Okay, so let's oh, go ahead.
So the can you go back to it real fast? The question.
Yeah. Okay.
Okay, so the number of days was the dependent?
Yes.
Okay.
Right.
That's all. I just wanted to reorient that.
Yeah. These are exactly the kind of questions that you're going to receive. And there's a big chunk of the exam devoted to this, to picking the appropriate test, knowing when you should test something, what test to use to address a specific question. Okay, let me see what else I have on here. And then I'll just open it to you guys. Whoop. Okay. All right. So, yeah, I would say, I would focus if it was me that was going to study, what I would do is I don't think I would read, this is going to sound really bad. I don't think I would go back and read the textbook. I didn't write the textbook. I wrote the exam. So what I highlight in the lectures on ANOVA, that is going to be more likely to be on the exam than the nitty-gritty stuff in the textbook, right? So I would rewatch the two-way ANOVA step-by-step, the one-way ANOVA step-by-step video, and specifically like focus on what an interaction effect means and how it's different from a main effect. Which, I mean, that kind of concept, I could go over it, but it's probably just easier. I probably explain it better than if I'm doing it off the cuff. In the lecture videos, I would focus on that because, I mean, when it comes to the computational, that's what's going to be tested is ANOVA. And I guess at this point, I'll just open it up for any kind of random questions that you might have going into this.
So I had a question. It's not really about the exam, but are you still going to have office hours tomorrow?
Yes.
Okay, because I would like to do that tomorrow if possible.
Perfect. Yeah, absolutely. Yeah, I'll have office hours tomorrow. I won't have them on the exam day though, for obvious reasons. But yeah, I'll have office hours tomorrow.
And is the like, are we going to be asked on like, so if we're asked on like what the conclusion is that also going to be how it was in the last exam where it's multiple choice and we just select? Okay.
Yes. Yeah, I try to stick to very similar format. And I do try to be as goofy as possible. Just, let me just, I'm just pulling up the exam right now so I can make sure with these kinds of questions that I'm able to be 100% accurate. Okay. Yeah, I'm just looking through to see if there's anything on here. I mean, make sure you understand how to read the SPSS output of an ANOVA, right? So if you're given SPSS output for ANOVA, be able to interpret that. Also, I'm going to hammer this again. I did it last review session, but it is just so challenging. People, it is so challenging to understand this. When P is less than 0.05, that means it is statistically significant, assuming your alpha was 0.05, right? But you want it less than 0.05 to be significant. In ANOVA speak, or in SPSS speak, the p-value is what's called sig, right? The significance. For it to be significant, you want that less than 0.05. So I'm just kind of going through, looking at these questions and trying to think if there's anything yeah, I'll tell you, there's a lot of pick the appropriate test questions.
What about like figuring out what hypothesis, like how to set up the null and alternative hypothesis? Like, is there like a ton of those, or is it just going to be for the computationals, or?
No, you mean setting up the null hypothesis in ANOVA? You like
Yeah, like is it going to be like where we type it in like the last one, or are we going to be doing any of that?
so I'm looking at that right now. So as part of an ANOVA problem, naturally one of the steps is going to be setting up the null and alternative hypotheses, but those are multiple choice on this one. The reason for that is because with ANOVA, there's a lot of different ways that you could, by typing in an answer, it's easier to do it with multiple choice. One thing that you definitely should focus on is how to fill in the ANOVA table, right? Like you get your sum of squares values, How do you compute the degrees of freedom? How do you compute the mean square? How do you compute the F? All of those, there's like, you will have to, in one problem, completely calculate everything in the ANOVA table, right? So, and all of this is just really part of, you know, the expectation of you understanding ANOVA. But there's, yeah, there's nothing surprising. Did I address your question effectively on hypotheses?
Yeah, we're just going to be tested on the ANOVA's hypotheses, though.
Yeah, right. In the context of like the computational.
Okay, yeah, that helped. That answered.
Yeah. I'm actually, my question scenarios actually aren't too crazy this time. I don't have you know, techno DJs and kind of stuff. Yeah, this, I have to say, I mean, I hate to be a broken record, but yeah, you need to be able to do an ANOVA. There's no surprises, nothing that's surprising. Most of, I mean, there's stuff where you do have to enter in numbers, but most of the questions are multiple choice. You need to know how to pick the appropriate test. That's what, I mean, that and ANOVA are what you need to focus on. If you're going to devote some concentrated time to preparing, that's what I would focus on. If you're able to master those two things, I bet you could get everything else wrong on the test and probably come away with a C. Maybe even a B, I don't know. Probably B.
And then how do we like tell again if we need to use like a Tukey test or the what I think it's called, like Omega, I believe. Like, is there like key things to how to decide which one to use?
Okay, so it all depends, right? So there's two types of tests. There are planned comparisons, which, think of the word planned, means like when you plan something, it's something in advance. So in other words, if I'm doing an ANOVA and I have treatment 1, treatment 2, and control, and I have a hypothesis specifically in advance that both treatments are going to be better than control, I might do a planned comparison to test that. If I don't, and I'm just kind of want to see how do all the groups differ from each other, more of an exploratory approach, then I'm going to use a post hoc test like the Tukey. So omega squared is a little bit different. Omega squared is what's used, it's the measure of effect size. So you're going to have like some kind of F value for your omnibus ANOVA, and omega squared is like the effect size that you use to, you know, and keep in mind, like, why would you use an effect size? Well, I mean, if we had 10 people in the study, our p-value is going to not be significant, most likely. If we had 10,000 people in the study, our p-value is going to be so small, it's definitely going to be significant, even if the difference isn't even that meaningful. It's just super, super small, right? It's like if you have a microscope, you know, the number of people in your study kind of are like focus, like how much you can focus in and see something. Well, sometimes whenever you have really, really large studies, they can see microscopic level nuances that in the real world don't mean anything. On the other hand, if you have really low population, you don't have the magnification to be able to see closely enough to say that something's going on when it could be going on. And so omega squared, which is a measure of effect size, is immune to that influence of or less affected by the difference in sample size. It's a measure of how big is the actual effect, irrespective of the sample size. So, so I hope that answered the question. So you're going to know when you do it, you're going to do a Tukey test or a planned comparison test. Well, let me back off. You'll do a Tukey test, a post hoc test, if you have a significant omnibus F value. That's when you would do it, right? And you would only do that if you were exploring the data. If you have a significant omnibus F value, in this class, if you have a significant omnibus F value, you would do a planned comparison if in advance of conducting the test, you had a hypothesis about what needs to be compared to what. Did that answer your question?
So you would do a planned before testing the hypothesis?
Well, it's like, say I had a hypothesis, going back to our example with small, medium, and large beverages. Say I had the hypothesis that people who drink small beverages are going to enjoy them more than people who drink large beverages, but I don't really care about medium, right? Well, if I have that explicit hypothesis set in advance before I even go out and collect the data, that would suggest that I should do a planned comparison, right? But if I collected the data because I'm curious, I don't really know whether there's going to be difference in preference based on drink size, then I would want to explore every possible comparison. And that is what you would use a post hoc Tukey test for.
Okay, I got it now.
Yeah. Yeah, there's a lot of, I mean, I think the driving, there's a lot of little nuance and stuff here, but it is ultimately the question that the psychologist has that should be driving the ship, right? And so that's why it seems like, well, why don't you just test it, just have one way to do it. But, you know, our questions can sometimes be nuanced and complicated, and there's a lot of statistics nerds out there to make sure that the appropriate technique is used for every single type of question. And so in a sense, I think, and this, for those of you who decide that you might want to go into like psychology at a grad level or something, one of the things that you'll find whenever you get totally immersed in statistics, which you will if you go to grad school. And by the way, the more statistics you can take before you apply to grad school, that will only increase your chances of getting accepted. So one of the interesting kind of paradoxes of statistics is that you think going into it that statistics is going to help you answer your questions. And it does, right? It provides results of whether the experiment was significant or not, and you can make an inference on it. However, what you find as you get more into statistics is that probably the more important thing that they teach you is how to ask questions and the types of questions you're capable of asking. And you know, statistics will kind of open you up to the possibility of new questions that you never even thought about asking before. And that's kind of cool, right? Because you don't expect that going in, but it teaches you how to be more curious and address those questions specifically. So, yeah. Okay. Any other questions? No?
I don't have any.
Okay. Well, I mean, I think I've got off my chest what I wanted to get off in terms of how you should prepare. And if you do have questions before the exam, do send me an email. I can obviously I'll answer your emails tomorrow and today and stuff. And if you have questions, attend my office hours tomorrow. Until then, I wish each of you the best of luck on the final, and there shouldn't be any surprises. And I'm rooting for everyone in the class. Cool.
Sounds
Yeah.
All right. Well, thank you for attending. And I'm going to go ahead and get this thing processed so that I can upload it and others are able to see what we went over. And thank you so much for your participation and for a great semester. And good luck as you move forward into your career as psychologists.
Thank you.
Yep. All right.